A dose of 75 milligrams of a drug is administered to a patient. The amount of drug in milligrams in the person's bloodstream at time t in hours is given by the function a of t. The rate at which the drug leaves the bloodstream can be modeled by the differential equation d of a over d of t equals negative 0.09a. Write an expression for a of t. All right, so this type of question, you might think, oh, I'm going to need to do separation of variables. I need to figure this out. Well, what we want to remember is that if we have a relationship where the rate of change is proportional to the actual value itself, this is an exponential model. I'm going to show you the general form, exponential model. When we have an exponential model, again, the general form of that is going to look like dy over dx will equal k times y. And so what will the actual expression for our function be? Well, we know from the lesson today that if we have a differential function like this, differential equation, we can say that y will equal some constant c times e to the power of kt. And those k's, I'll highlight these in red, are the same. So in this question, what's our k? Well, we know that our k is negative 0.09. So we can write out a differential equation. So a of t, that's our y, is equal to c. Well, we don't know what c is yet. Actually, I haven't named it yet, but c times e to the power of negative 0.09 t. Well, what is c? C represents, I'll do this in yellow, our initial value. Initial value. And in this question, what's our initial value? What's the amount of drug that is in the bloodstream at time equals 0? At the very beginning of the question, we can see that we're given a dose of 75 milligrams. So our initial value, that C, is going to be 75. And so in the end, we'll get a function, I'll write it all in yellow, a of t equals 75 times e to the power of negative 0.09 t. And here we are given a function to find the amount of drug in the bloodstream.